Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, that is Trionic Array 2. So before solve this problem, you should solve the previous day's problem, that is Trionic Array 1, so that your concept would be the clear. Now in this video I will explain a few things, like first explain the question, then simulate the test case, build the intuitions and discuss the solutions approach, and finally code explanations and complexity analysis. And additionally I will also discuss the space optimized versions of the code. Normally I will show you the code for the big O of, you can say it would be 3n space complexity for initial versions, and in the space optimized version I will show you the big O of 1 space complexity. So without further delay, now let's start the video. So basically problem is given a nums array. This is given a nums array which is an integer array, and also there is given an output. So to what we have to do, the trionic subarray, what it means, let's say from nums L to R, L to R is a subarray, that means it's start from L and end at R, both are inclusives. So this is the subarray, and as you already know, subarray is the contiguous locations, and the so trionic subarray, and also the like 0 less than or equal to L and less than R and less than N. This is the range given, which is too much obvious, and there are three conditions. That means nums L to P, let's consider this way. Let's say there are some elements, this is the P index, and some elements Q index and R index. So these are the index L, P, Q and R. So 0 L to P, these portions have to be strictly increasing. That means it will be these fashions, not even flattened fashion. So strictly increasing, that means it will be strictly greater than the previous element. And another portion is P to Q, that means these portions have to be the strongly decreasing. So this will be like this way, these fashions. And last portion, that will be Q to R, this will be also be strictly increasing, so these fashions. So these are the three conditions given for the trionic array to be a trionic array, a subarray to be trionic array. And also the conditions over here is L less than P less than Q and less than R. And if you solve the previous problem, like trionic array 1 problem, which is the previous day LeetCode problem of the day, so you will get this idea with clarity. But that was a easy problem. I will explain by considering you haven't solved that problem. So yeah, and the task is given over here is we have to calculate the maximum sum of any trionic subarray in the nums. So in the nums array, let's say there are so many elements, and there are so many possibility of the trionic array. Let's say these are the first trionic array, then sorry, it won't be like, let's take 4 elements. So this is a trionic array, let's consider, and also be this is a trionic array, and you have to return whichever sum is maximum. So that is our task. So we have to find the optimal trionic array, so trionic subarray, so that it would be the sum is the maximum. Now if you simulate the test case, this is the first test case given in the LeetCode example. So 0 minus 2 and 1, if you look into this, so 0 to minus 2, it is decreasing, that means this way. And minus 2 to 1, this is also increasing. And minus 1 to minus 3, again decreasing. Minus 3 to 0, increasing. And 0 to 2 also increasing. Okay, 0 to 2 and 2 to minus 1 is also decreasing. Now we want to find first increasing, then decreasing, and then increasing. This is the conditions of the trionic subarray. So we just look into this pattern wherever it is occur. So if you start over here and first it's increasing, then decreasing, and then again increasing, and we stop over here. This is a valid Trionic survey. That means we are starting from -2, so we can go up to 0, or we start from -2 and we can go up to 2 element. These are the two possible cases for the first example. That means -2, then -1, -3, and 0. This is also Trionic array subarray, because -2 to -1 it is increasing, then -1 to -3 decreasing, and again 0, this is increasing. This is one possible case, one possibility 1. And another possibility is -2, -1, -3, 0, and 2. So it is also similar way, that -2 to -1 increasing, then -1 to -3 decreasing, and -3 to 0 increasing, and 0 to 2 also increasing. So this is another possibility. Let's consider possibility 2. So if you sum these elements, you get the answer of -2, -1, and -3, so -6 over here. And for this possibility, that is possibility 2, sum would be given as -2, -1, -3 plus 0 plus 2, so that will give you um, -4 as answer. So you have two valid choices, -6 or -4. So whichever is maximum, so -4 is maximum over here, so we just give the output as -4. This is where also is given as -4. So now let's consider the second example. This is given as 1, so 1 to 4 it is increasing, then 4 to 2 this is decreasing, and 2 to 7 also increasing. So this is also a valid choice, first increasing, then decreasing, and then also increasing. This is a valid choice of the Trionic survey. So over here you get the sum as 1 plus 4 plus 2 plus 7, so it will give you 14. So there is only one choice is valid. So I think you got the problem. Now look into the constraint part. So constraint is given as n value, which is nums dot length, that is go from 4 to 10 to the power 5. Why it's limited as 4? Because you cannot build any Trionic survey less than 4 elements. What it means, to get this sequence like increasing first, so this number have to be there, and this number is smaller than this one, and you have also decreasing, this is smaller, this should be smaller than previous one, and also get the increasing part, so it should be greater than the last element. So you need at least 4 elements to get the Trionic part, at least one. So that's why it is given as 4 as the minimum boundary for this answer, like this constraint. And also given the nums of I, which can go minus 10 to the power 9 to 10 to the power 9. This is important because we have to use the long to like adjust the answer, because if you sum all the elements which have value of 10 to the power 9, uh, like 10 to the power 5 times, let's say this is 10 to the power 5 times, so it will easily out of bound of the integer. That's why we have to use the long part. And also additionally, one constant is given, at least one Trionic subarray exists. So this is the this constant given from the LeetCode. So they build the test case such a way that there is at least one Trionic subarray exist. So now let's come into the intuition part. So the Trionic pattern, you already get the correct, like first of all strictly increasing, what we want to find in the answer, like in test case, then strictly increasing, then strictly, okay, strictly decreasing, and again strictly increasing. This is the Trionic part. But how to know which portion to take? Like, you got the answers, like let's take an example. First of all, you have 1 2 3, and then you can say 2 1, and again 1 2 3 and 4. This is a long sequence, like it is first of all increasing up to this point, then it is decreasing, and then again increasing up to this point. So this is one valid answers. But if you look into the smaller portions, let's say you start from 2, these portions 2 3, so it is increasing, and from 3 to 2 decreasing, and also 2 to 1 is also decreasing, and 1 to 2 increasing. So if you close into this part, this is also a valid summary. But is it give the maximum answers? Maybe not, because the whole portions give the maximum answers. But sometimes the elements also negative, so you cannot say that always taking the maximum length subarray is the maximum answers. So how you know that the which portions to take, like where to start and where to end? To do these things, we have to try, we have to try all possibility, all possibility. What it mean? Like you can think this way, let's say brute force approach. Brute force approach, you try all possibility. That means whenever you get this sequence, and first of all, let's say you define the mm, uh, each increasing portions. Let's say either it's increasing, otherwise it's decreasing. No, let's consider this way. So if you whenever you find these portions, or the smallest or the largest, so you take that portions and calculate the answers, and each time you track the answers, that what is the maximum sum. That way you can do the brute force approach. But if you do this way, so you are going to do the solve in the big of n square approach. But n square over here is not acceptable, because n goes as max as 10 to the power 5, so it will give you the time limit exit. So we cannot try each and every possibility in brute force way. So we have to find some way so that we get the answers optimally. So here you can think it is as the like dynamic programming problem, that is DP problem. And there are few states if you look into this. So let's break down the whole problems into few steps so that you can think it is as DP. So first of all, it's first step is up state. That means these conditions. So it simply means that nums of I is greater than nums of I minus 1. That means current element is greater than the previous element, that is up state. And from the up down, and that means these steps, we are first we are calculate this one, that is strictly increasing only up, and then already increase then decrease, this one is the second step, and increase then decrease and again increase, this one the third step. And we want to reach over here. So to reach over here, we need to follow previous two steps. Let's say first of all it is increasing, then increasing decreasing, and then increasing decreasing and again increasing. These are the three steps, and if we calculate these three steps sequentially, then we get the answers, and also we try all the possibilities. Now let's come into the solutions approach. First of all, we are taking few vectors. That one, first one is dp1 of I, dp2 of I, and dp3 of I. And first one is considering the first ascent. That means we are first try to solve these states. That means strictly increasing. So you that is the only the first steps, that is up state. So if you look into this, so it is first ascent. And when these states occur, like whenever nums of I is greater than nums of I minus 1, that means nums of I, this is the current element, is greater than the previous element. That means it's strictly increasing. So if this case occurs, then we have the two choices to update the dp1 of I. So first of all, we are processing, let's say there are so many elements in the nums array, and we try to process this element. This is the ith positions, and in these ith positions we just calculate the dp1, dp1 of I, and dp2 of I, and dp3 of I, and at last we just return whatever the maximum of dp3. Why dp3? Because in the third state we have the complete complete picture. In the third step all these transitions is calculated optimally, so we have to return the maximum of dp3. So first of all, when we calculate the dp1 of I, so we have two choices. What are the choices? That means we just want to calculate the maximum, like we are in the positions of I over here, and we want to calculate the maximum value if we reach that steps, that positions with considering that is strictly increasing previously. That means there are two steps, like start a new sequence. We can start the new sequence. That means we start from nums of I minus 1 and nums of I. These are the starting, this the starting sequence, like from starting from the nums of I minus 1, and that will be the sequence. You can update this is as dp1 of I equal to nums of I minus 1 plus nums of I. This consider as starting from nums of I minus 1, and another one is extend. That means we already let's take an example. Let's say 1 2 3 and 4 and 5. So let's say we are processing at the element of 3. So we have three choices. Either we can start from 3 and go process till end, and otherwise we already have a sequence, let me, that is 1 2 3 this way. So we just continue that sequence to get the better answer. There are two choices, so we extend the previous sequence. That means dp1 of I equal to simply dp1 of I minus 1 plus nums of I. That means we are considering the current element. These are the two steps for the dp1. Now go to the next steps. That means descent. That means we already have this way, that increase and then decrease. We are just calculate these portions, decreasing portions, strictly decreasing portions. So these conditions when we have to apply, when nums of I is less than nums of I minus 1. That means nums of I is the current element and nums of I minus 1 is the previous element. When the current element is less than the previous element, that means previous element is greater. So in that case we have two choices. Either we transitions from phase 1, that means we have already calculated phase 1 value, that is strictly increasing, then we start calculating for the phase 2 value, decreasing portion. This is the transition states. Otherwise we already calculating the decreasing portions and we just want to continue that decreasing portions. That means let's say we have, there are so many elements in front, and let's say 4 3 2 1. So if we process this element, let's say 2, this is the I over here. There are two choices. Either we can transition from phase 1 to phase 2, which is not possible over here because already phase 2 is continuing. So there are only one choice, that phase 2 is continuing, and we just continue, extend the phase 2. So there are transitions. That means over here you can think about this way, that dp2 of I equal to dp1, that is for the phase 1 of I minus 1 and plus nums of I, because we are considering the current element. And here we are just extend the previous decreasing sequence. That means dp, we already enter into the decreasing sequence and we just want to continue that. So dp2 of I equal to dp2 of I minus 1 and plus nums of I, that is the current element. There are also two choices. And if you look into the third example, that means this is the last scenario. So we are just on to calculate these portions. So that means this is the second ascent positions. When we have to calculate these positions, that is nums of I is greater than nums of I minus 1. So if you look into this, let's say you have a sequence of this way. Okay, so if you calculate these portions for the first subarray, then you can start these portions which is for the second sub-array, and so these portions is common for both. So you just start over there. That means whatever, let's say there is a valid Trionic sub-array which ends these positions, and you can start for the next Trionic sub-array from these positions only, because first state is increasing and the third state is increasing, so you can start over there. So that's why we just applying the same conditions over here also. That means nums of I is greater than nums of I minus 1. That means current element is greater than the previous element. So in that case we have two choices. First choice is transition from the phase 2. That means we already calculate these portions, sorry, okay, so we already calculate this portion. Oh, we calculate these portions. That means we first calculate increasing then decreased portion, and we just want to calculate the last increasing portions. This is the first choice. And second choice is we just extend, we already start calculating the third state, we just extend that state to get the better answer. There are two choices, so you can just update this way, that dp3 of I, if you just want to transit from the phase 2, that would given as phase 2 is dp2 of I minus 1 plus nums of I. And for the second choice we just extend that for like current page, so it would be like dp3 of I equal to dp3 of I minus 1 and plus nums of I. This will increase the third state, and at last we just return the maximum of dp3. That means whichever element is the maximum in the dp3 array, we have to return that. That would be our answers, because in that case we just consider whole state as in final state. Now, but how you handle if the nums of I equal to nums of I minus 1? What if the sequence is 1 1 2 2 and this way? That means let's say this element, first element, the like current element is similar same as the previous element. How you handle these situations? First of all we first of all initialize all dp array as minus infinity to track them, to get the maximum answers. And if we just applying the conditions over either greater than sign or less than sign, that means over here we are applying conditions greater than or less than less than sign, so we're not mentioning that equal sign. So if it is equal, then the dp of that particular index, it is minus 1, and minus 1 is propagated till end. So we did not update the answers, and at the end we just return the minus infinity as an answers. This is the invalid choice, and that is properly fine. Now I will discuss the coding part in the C++, but you can see the Java and Python code in my like LeetCode discussions tab. I will attach that link in the descriptions. Now let's jump into the coding part. As I already discussed in the solutions approach, like over here, and how we are deal with the DP array, and similarly I will just go through the coding part and you will get the coding. Like first of all, first of all you have to take the long. So to avoid write whole word long, we just define ll long. Now start from over here. This will be already given, and const ll infinity equal to 1e8. What it mean? It will be the simply 10 to the power 18. So so as I already discussed, we have to initialize all the dp array by minus infinity. That's why we just defining this is the infinity. Now maximum Trionic, let's start from here. Okay, so n equal to int n equal to nums dot size, and if n less than 4, then we return -1. Why? Because less than 4 elements we cannot get the trionic part. So although there are already given as it should be greater than or equal to n greater sorry less sorry 4 less than equal to n less than equal to 10 to the power 5, already this is given, but still we are just doing this for safety. And first of all we define the dp1 dp2 and dp1 dp2 and dp3. I already discussed this is the maximum sum ending at I for the first increasing sequence, similarly for decreasing sequence and second increasing sequence, and all are initialized as minus infinity, all are infinity initialized at minus infinity. And we take the max long max yearly, that means it will track the maximum sum answer. Now we go through the each element starting from 1 to n, because at the first positions, zeroth positions, there is no sequence, like there are no previous elements, so there is no sequence, it's only sequence starting from either increasing or decreasing sequence starting from the first element. So we are just starting from the iterations I equal to 1, and now we check whether it nums of I greater than nums of I minus 1, whether it is greater than the previous element. So we have two phases, this is the phase 1 and phase 3, that means this is the increasing sequence. So as this is the valid, so this is first phase and this is the third phase. We just calculate first and third phase calculations. For the first phase, as I already discussed, we have two choices. First we starting a new sequence and another one is extend the sequence. So starting the new sequence will give you the nums of I plus nums of I minus 1, as I already discussed. And for extending the existing sequence, that will give you the dp of I minus 1 plus nums of I. And for phase 3 calculations, that is second increasing, that means these portions. So it's also have the two choices, options A, option A will give you the transitions from the phase 2, that means we already calculate this much portions and we just want to calculate this one. So we just transition state from the phase 2, that means we just simply check whether last element, that means dp2 of I minus 1 not equal to minus infinity, that means whatever we are calculating till now, then that will be optimally stored as dp2 I minus 1. And if it is even infinity, then we do not need to calculate. If it is not infinity, that means it's a valid answer, and we just continue, we just start transitioning from that positions. So we just update it maximum of dp3 of I and dp2 I minus 1 plus nums, as I already discussed. And also the for the option B, we just extending the phase 3, that means if last element is non-infinity in the dp3, then we just we just add dp3 I minus 1 plus nums, we and as also assigned to the dp3 of I. Now this is for the increasing portion. Now we have to discuss for the decreasing portion, strictly decreasing portions. If nums of I is less than nums of I minus 1, that means previous element is greater, that means it's a decreasing sequence. And this sequence only for the phase 2, because this is the valid answer and we just want to calculate this portion as the decreasing. So here also two options, transitions from the phase 1 state, that you can say if the dp1 of I minus 1 is not equal to infinity, then we just update dp2 of I equal to maximum of dp2 of I and dp1 I minus 1 plus nums. That means we just transit from the phase 1 to phase 2, and second option would be the extended state. So we can extend the phase 2, that means if the last elements of the dp2 is not infinity, then we just add that element and assign to the dp2 of I. And all these calculations done, we just track each time max el equal to maximum of dp max el and dp3 of I. That each time we calculate the dp3, we just track the what is the maximum element, that is the maximum sum. So if it is at last, we just return that thing. Now this is mainly the coding purpose. As you already see that there are always two choices, either continue or either starting, and either from the transitioning state. So if you look into the time complexity part, and we are go through the over here we taking the big O of n time complexity, and apart from that we did not take any extra time. So time complexity would be the big O of n time complexity. And if you look into the space, so we are taking like 3n extra space for the three vectors. So it will be like big O of 3n space complexity, but I will show you the optimized version. Now carefully look. When you transitioning dp state, where it will be like over here. So you need to calculate dp1 of I. You needs dp1 of I minus 1. If you need to calculate dp3 of I, you need dp2 of I minus 1. And if you dp3 over here, so dp3 of I minus 1, and dp2 over here, you need dp1 I minus 1, and dp2 over here, and you need dp2 of I minus 1. And yeah, so if you look into this, like whatever calculations you need in the current states, you just need previous state informations. You do not need whole array. So instead of taking the whole array as in dp states, we just need three variables, like six variables actually. So these variables will save for the previous state, and this for the current state. So in this way, with the six variable you can calculate the answers, and I will show you below. So over here also the code is almost similar. We just update this one, d1 as dp1, d2 as dp2, and d3 as dp3, and all are initialized as minus infinity, as all variables are initialized as minus infinity. And this is exactly same, and we just starting from the I to n 1 to n, and we just also taking another sets of three variables, that is current 1, current 2, and current 3. So it will save the current process of the dp1, dp2, and dp3 states. So as the current process is done at the end, we just update d1 equal to current 1, d2 equal to current 2, and d3 equal to current 3 for calculations of the next steps. So if you over here, space complexity would be big O of 1, because we are using constant space, but time complexity still remains the same. This is the space optimized versions. Now if you guys find this is helpful, so please subscribe the channel and share also. And thanks for watching. Stay tuned for the more videos, and I will also attach the notes in description. Thank you guys.